All right, good morning, Math 1. If you were on our Math 1 Zoom meeting yesterday, you already have these solutions. But if you weren't there, I will go ahead and complete the Unit 8 Quiz 1. Hopefully you did it on your own, and now you're just using my video to check your answers, and you are not just copying all my answers, because in the long run, we've talked about that many times, it won't help you. Okay. Rotate 90 degrees counterclockwise about the origin. So counterclockwise would be this way. So we've talked about the rule for any 90-degree rotation. You switch your X and your Y. And then since we're going to the rotating to the left, we want to think, okay, our left is the X value, so the X value becomes the opposite. Alright, so let's just take R, which is at, where are we? R is at 5, -4. So we switch our X and our Y, and our new X becomes the opposite. So R prime is going to be at 4, 5. Okay, that's R to R prime. Okay, S is at 8, -4. So we switch our X and our Y, and our new X becomes the opposite because we're rotating to the left and X is on the left. So 4, 8. And that will be R prime and S prime. All right, T is at 8, -9. So we switch our X and our Y, and our new X becomes the opposite. So 9, 8. And that is T prime. And finally, this is T prime and S prime. Finally, Q is at 3, -9. So we switch our X and our Y, and then our new X becomes the opposite. Excuse me. Okay, so 9, 3. So we are at 9, 3. Q prime. We get our straight edge. And there we have our new trapezoid. Okay, moving on to number 2. All right, using the diagram below, first describe in words the transformation used to create triangle STU, including the coordinate notation rule in your answer. Okay, so we're basically moving, this is our pre-image, and we're moving this to here. Hopefully you can see that that is a reflection over the x-axis, so we're going to write that. And what we would say is, when we reflect over the x-axis, our x and y stay in the same place, but our y becomes the opposite. When you're reflecting over the x-axis, your x value stays the same. See, they're both at 4, -4, but we went from positive 12y to negative 12y. N and t are both at -14. Okay, -14, -14 for their x values, but their y value went from 12 to -12. And M and S are both at -16 for their x value, but M's y value is 16, S's y value is -16. So your x's stay the same, your y becomes the opposite when reflecting over the x-axis. Okay, identify the congruent angles of the triangle. So I just drew lines. Angle O is congruent to angle U. Angle N is congruent to angle T. And angle M is congruent to angle S. Identify the congruent sides of the triangles. All right, well, you can probably tell with the lines too. Line segment NO is congruent to line segment TU. Okay, and let's go NM is congruent to TS. I put NM, or NM is congruent to ST, just to keep the numbers all in order. And finally, MO is congruent to an MO, so we'll say SU. Okay, moving on to number 3. All right, number 3, rotate triangle XYZ 90 degrees counterclockwise around the origin. Okay, so again, we're going counterclockwise, so that would be to the left. So same rule we used before, XY, switch places when we rotate 90 degrees. But since we're going to the left, X is on the left, so our new X becomes the opposite. All right, so X is at 0, 3, so we switch our X and our Y, and our new X becomes the opposite, so it's at negative. So that's X prime. And then call that X and X prime. We'll go Y is at 5, 5. So not much switching to do there, right? Still 5, 5. But our new X becomes the opposite, so it's negative 5, 5. And that's Y prime. And our last one is Z. Z is currently at 3, 2. So we will switch 2 and 3. But our new X becomes the opposite, so negative 2, 1, 2, 3. And we have triangle XYZ reflected or rotated 90 degrees counterclockwise to triangle YXZ. So you can see Y is kind of up in the corner, so it traveled over here. You can see that Z traveled here and X traveled over there. Okay, what is the slope of XY? Well, XY is right here, so the slope, we say M of XY equals, we can just count. Rise 2, run 5. Rise 2, run 5. What is the slope of X prime, Y prime? Well, here's XY, and we're actually going to go down 1, 2, 3, 4, 5, and run 2. So the slope of X prime, Y prime is negative 5, 2. So hopefully you can see that these guys are opposite reciprocals. And you got to go back to last semester when lines have opposite reciprocal slopes, they are perpendicular. Okay, the line segments are perpendicular. And anytime you rotate 90 degrees, you know that's going to happen because here we're facing, if we think about east, west, north, and south, I'm facing north. If I rotate 90 degrees, I'm now facing east, and that's a 90-degree turn. Or think about 12 o'clock noon and 9 o'clock. Okay, 12 o'clock and 9 o'clock. Oops, right about there. There's a 90-degree rotation. So those two line segments are perpendicular or at 90 degrees from each other. Okay, a right angle. Okay, last one. Draw an example of two triangles that do not have rigid motion. Explain what it means when a transformation has rigid motion. Okay, two triangles that do not have rigid motion would be two triangles that basically change their size and their shape. Okay, what we will do at some point is when you do what's called a dilation. If we have a triangle here, you'll learn this. If we have a dilation, what can happen is, if you think about how your eyes dilate in the dark, they open up. A dilation is when a triangle actually grows. Now, in a dilation case, the triangles actually retain the shape, they just change their size. So this triangle just got bigger. My drawing isn't perfect, but these two triangles would be the same shape, just different sizes. So there's a couple of examples of when we do not retain rigid motion, because rigid motion is when a figure retains size and shape through transformation. So remember, when I say transformation, I'm talking about the three types of movement we have, which would be translation. Translation, that's a slide. And then we have reflection. Reflection, which is a flip. And a rotation, if I can squeeze it on there at the very bottom. I don't know if we have a nickname for rotation. Guess we could say a turn. I don't know, we usually don't have a nickname for rotation. You guys are pretty good at understanding what rotate means. All right, so there's the quiz. Thanks for listening.